This year, I got an absolutely fabulous gift for Christmas. In fact, every time I've gone on about it to my wife, her eyes roll straight up into the back of her head. So I just know you're going to love this too. That's right, a genuine HTP slushy machine for making, slushies. Snow cones, water ice, non-copyright infringing Slurpos, that sort of thing. All right, settle down now. Let's try to be serial here. This is a water cooler for a TIG torch. It's full of water, or it will be soon anyway, and its only job is to keep that water cool. I suppose it would probably work fine for a water-cooled MIG gun, your kid's 20-gallon inflatable pool. Probably won't do much for your beer unless you're really into room temperature, but it's sold by HTP for their 221 TIG welder. I mean, they come in a few different variants. You can get a water cooler for your TIG torch. It doesn't have to be specific to the 221. This one just happens to have the plug that fits on the back of the 221, so it comes on and goes off with the TIG welder. Again, it's the Arctic Chill 5460, and full disclosure, I got this thing for free. So, quick backstory. A week or so before Christmas, I got a really nice email from a fellow who goes by the name of Jeff Noland. I think he's the owner, president, and current heavyweight champion of USA Weld. He said he really enjoys my videos, liked what I did with the 221, and was willing to send me a water cooler for that TIG welder as a Christmas present. I gotta be honest, a little part inside of me feels guilty for what's about to happen. Jeff, I really do apologize, but science. And I suppose the old saying is true. You really shouldn't kiss a gift horse on the mouth. Okay, Jeff, go. This old Tony, I'm sending you a Christmas present. Jeff, no. I really couldn't accept something like that. Old Tony, I insist. I'm sending you a water cooler. I do appreciate that. I really, really do. But you realize that if you send me a water cooler, I'm almost certainly going to take it apart on camera and probably not leave well enough alone until it's broken. No, I'm sending it. It's yours to do whatever you want with. What? And here it is. For two reasons. First, this thing is going to be a lot of fun. And second, I'm not an idiot. That's a free water cooler you're looking at. Come on. Now, before I tear into this thing, and at the risk of boring some of you, let's have a quick talk about what and who a TIG water cooler is for. There are really two types of TIG torches. The ones you can see and the ones you can't. Air-cooled and water-cooled. If you have a TIG welder at home, odds are it's probably an air-cooled 17 like the one you see on the left. They call them air-cooled torches, but they're not really cooled by air. I mean, maybe a little, but technically they're gas-cooled. The argon flowing through the hose and out the cup helps keep your torch cool while it welds. Now, you may recall that this is the business end of the torch, or what would be the tip of the tungsten if one were installed. And it's pumping out some major heat, keeping your weld puddle molten at like a gazillion degrees. Your hand usually starts out holding the torch about here, and if you do a lot of welding, your hand might end up somewhere back here by the time you're done. These things can get pretty toasty. Of course, that depends on what amperage you're welding at and how long you weld for. And while you're welding, colder gas coming through the hose in an air-cooled torch helps keep the torch from melting away into oblivion. Again, if you're using it at or below its current rating. This torch here I think is good to 150 amps. What that means is it can weld at any amperage up to and including 150 amps without destroying itself, assuming it's got gas flowing through it. You of course also need that gas for shielding, so you probably wouldn't be welding without turning your gas on. Not for very long at any rate. Okay, so 150 amp torch. But my TIG welder is 220 amps. What now? Well, you might have three options. First, don't weld at 220 amps. Second, you could get a bigger air-cooled torch which has a higher amperage rating. Or third, you could get a water-cooled torch. Water does a much better job at carrying heat away from the torch than air does, or gas technically. You don't have to take my word for it. Go ahead and try it yourself. Light both your hands on fire. Try blowing on one hand and putting the other hand under some running water. Now you tell me. Which one feels better? Other than pound for pound being able to weld at a higher amperage rating, there are some other benefits to water-cooled torches. Not only will the torch not disappear in a puff of black smoke at higher welding currents, but it'll also stay physically cooler in your hand. It's more comfortable. The water does protect the head of the torch, but it also keeps the whole torch temperature down. In addition, as you can maybe see here, water-cooled torches and components are usually a lot smaller. All of those things come together to make the welding experience more comfortable and easier to manage. But alas, with water-cooled torches, it's not all coming up Millhouse. You're dealing with, well, water. Not well water, just water. I mean, maybe well water. Anyway, you're dealing with water. Hoses, fittings, plumbing. There are more things that can go wrong. You need more stuff. And your rig suddenly becomes a lot less portable. Of course, in those cases, you can simply unplug your cooler and drive out with just your air-cooled rig. But I digest. Okay, enough about torches. Let's talk more about me. If you follow this channel, you may recall that I resisted going to water-cooled torches for quite a long time, partly because of the potential mess, but mostly due to the noise. Water coolers make noise. Now, to be fair, I haven't fired this thing up yet. It doesn't have any water in it whatsoever. And what I'm most curious about is what this thing sounds like. You see, I like quiet. I like that the 221 is quiet, that it makes as much noise as my toaster. For those of you out there that might be mechanically faint of heart, don't let this intimidate you. It really isn't all that complicated. In fact, this thing really only has two things going on the inside. First, tucked down there nice and cozy is a small pump. This is what keeps the Kool-Aid flowing out to the torch and back again. Second, at the back here, there's a nice looking 2-row radiator. I mean, it's a heat exchanger and a fan. That, of course, is what does the cooling. As is common to these smaller water coolers, the pump and fan are run by the same motor. So I mentioned this was a 2-row radiator. What that means effectively is the radiator is actually twice as big as the footprint that you're seeing. It's just that it's been folded on itself. So hot coolant comes into one of these two tubes, snakes its way down, turns around, comes back up, and out the same location at the top. That gives the coolant essentially twice as long inside the cold airflow, cooling it down. Now, I don't know how other water coolers do this, but that's a nice touch. If we look at the fan blade geometry, we can deduce that the motor spins this way, right? The fan blades sort of scoop up air and push it through the radiator. Since the fan and the pump are on the same motor shaft, I guess we now know which way that pump turns. It means the pump impeller is doing the same thing, which means this is the high pressure line. This is the pickup line, goes through the pump, and it spits it out here. Let's follow this around to the other side. And sure enough, this is the one coming out to the cold water out. That'd be cold pressurized water going to the torch. Or cooler, rather. Not necessarily cold. Hopefully cold, but not necessarily. Okay, so this top one is the pumped water going to the torch. And unless somebody ran over your leads with a forklift, the water goes through the torch, picks up heat because you're welding, and comes back into the bottom here. Since that's hot now, it should go to the radiator. Let's follow this bottom hose around. And sure enough, that's where it goes, right to the radiator. Now, in this line, there is some type of pressure or flow sensor. You remember that bit about your hoses being run over by a forklift? Well, if that were to happen, or you sat on the leads, or you've got a smart-ass 5-year-old that thinks it's funny to kink the hoses, that would disrupt either the flow or the pressure, and this sensor would pick that up. The sensor is powered by this small step-down transformer. Best as I can tell, it's taken 220 volts from the HTP welder in the case of this variant, and it's powering the sensor and an alarm up here in the front panel. And there's what it looks like on the front. Again, I haven't tried this yet, but by the looks of it, sort of the size and the holes in the front, it looks like it's both visible and audible alarm. It's also got a power switch for the unit and the ability to turn on or turn off that flow alarm. Not quite sure just yet why you'd want to do that, but if I figure it out, I'll let you know. According to the label, the motor is Italian made. It's half horsepower. The pump is good to 8 liters per minute at a head of 30 meters. I don't know the first thing about water coolers, but to me that sounds like a lot. Just looking at it, it appears to be well built and well assembled. Everything is zip tied into place. It is a little bit bouncy when it's opened up like this, but that top cover makes up 50% of the physical structure. And finally, we've got a little tiny fluid reservoir here and a gigantic start capacitor. It looks like it has a drain plug on the bottom. It's a nice touch. Now, just between the two of us, I've got some nefarious plans for this thing. But before I try to hatch those, I'm going to fill this up and test it as is, like right out of the box, effectively. I'm curious to hear how it sounds, and it'll give me a benchmark if I start fiddling around. Now, unfortunately, I didn't have the foresight to order the special sauce that these things are supposed to be filled with. What you just saw me add was distilled water. If you live somewhere that never sees freezing temperatures, just plain old distilled water is probably fine. Around here, however, it regularly gets below freezing and I'm in an unheated garage. That's a bad mix for these things. Heck, it's a bad mix for me. And just like in your car, you really don't want the coolant freezing and breaking its way out through your cooler or your torch aliens style. What you see me adding here is expensive heat transfer fluid. This stuff is used in closed-circuit solar heating systems. I mean, it's basically antifreeze, some sort of glycol. Without any fancy additives, they put in automotive antifreeze. Now, general consensus seems to agree on not using automotive antifreeze in these things. In fact, the manufacturer even went to a lot of trouble to print that right on the case. Automotive antifreeze will damage the pump. Now, of course, there are a ton of people out there that claim they've used auto antifreeze and never had any problems, because of course there are. The claim is that the automotive stuff has a ton of additives and detergents meant for engines and could in time cause damage in a water cooler because of the small passages in the TIG torch or all the different materials that the fluid would come into contact with in here. I guess like the pump, for example. Some think it's a way for a manufacturer to stiff you on expensive special cooler formulations. And maybe. I mean, I have no idea. I'm no pharmacist. Do your own homework. It's your water cooler after all, and put whatever you want in there. It's also recommended that you change the coolant annually, though I'll probably just do it the old-fashioned way. All right, well, that was pretty easy. I've got the torch lines installed. It's plugged into the back of the 221 in this case. I've got it down here on the floor near where it will end up living. It will sit on the bottom shelf of the cart. And to be completely fair, it's not as bad as I was expecting it to sound. Like, frankly, I don't feel like I'm talking louder or having to talk over the cooler. I mean, it's definitely there and running. But if you watch some of the other videos that are floating around online, when they turn it on, it's always sounded like a monsoon. Like, you know that sound of standing next to a big box fan installed in a window? That's what I was expecting. Anyway, to give you a better sense of what this actually sounds like, or as good of a sense as I can portray over video, let's take some sound measurements and compare it to some other tools around the garage. Oh, and while I'm here, this is what the flow alarm sounds like. Pretty cool. Unfortunately, I don't have a sound level meter, but my wife just got one of these new fancy phones for Christmas. She's upstairs taking a nap, so maybe we take a few measurements before she knows any better. Oh, whew, it still works. For a second there, I thought I was going to be in trouble. Okay, so the background is somewhere around 25-30 dB, and it looks like when I talk, 67, 70, somewhere in that range. Just turn on the cooler. Oh, by the way, the mic is about, 4 feet away from the water cooler and the welder. Obviously, you'll be hearing noise from both of those, but the mic is about where I'd be with my head while I'm welding at the bench. Here goes nothing. Sorry, when I just said mic, I meant the phone. Let's try some other tools. This is an impact driver on setting 3 and at about, 16 or 18 inches away from the phone. If you're anything like me, you probably don't run your hand tools 4 feet away from you. Cordless angle grinder, about the same distance. Corded angle grinder, and no, I don't work for Milwaukee. Well, there's a fun fact for you. My corded angle grinder has always sounded a lot louder to me than the cordless, despite only measuring maybe 2 or 3 dBs higher. So those results weren't really what I was expecting. put a few kinks in my plans here. This water cooler, at least in my space here, down on the floor behind me, sounds more or less like, I don't know, central air maybe. Maybe a smidge louder. And the plan in the back of my little head was to... wait a minute. I know what we should do. Okay, I'm going to need to order a couple of... Bear with me just one moment here. One of those, maybe one of those. Take 2 of those. No, 4 of those. That looks good. Sheesh. Don't you just hate waiting for online deliveries? They take forever. Originally, my plan was to try to tune this thing, make as many tweaks as possible to the existing kit to get the noise down. Now I'm second guessing how much bang for the buck I might get doing that. Earlier, I said this cooler has fundamentally 2 functions, pumping and cooling. And by the sounds of it, quite literally, it seems apparent to me that the fan is a much larger contributor to that noise than the pump is, with most of the noise coming from the fan and the radiator, from the air sort of being sucked in and pushed through the cooler. The rest, of course, would be the motor, the pump, and the line noise as coolant is pushed around in all this small tubing and fittings and elbows and stuff. In fact, you know what? Let's give it a try. Let's take this fan out, close it back up, and try it again. Just kidding, don't take stuff apart like that. This had a small screw in the center holding it into the end of the motor shaft. Okay, so hopefully no surprise there. No fan makes for a quieter cooler. The fan is a stamped aluminum part, 8 inches, 200 millimeters. As you'd likely expect from a stamped part, one side is quite sharp. It's the burr from stamping. You know, I'd bet just stoning that off would take out some of the high frequency noise, which is usually the most annoying. Initially, what I thought I might do was modify this fan. We'll get into that crazy logic in just a second, but what I was thinking of was either making the fan smaller, like physically trimming it, flattening the fan out, which would displace less air. In fact, stamped on it is 25 degrees. I assume that's the blade angle on the fan. I haven't measured it, but that looks about right. Maybe reduce that to half-ish, 15 degrees or so. I also thought about making my own fan, like CNCing something out of some plastic, maybe aluminum, slightly smaller with different blade geometry. But like I said, I don't think that's going to get us as much bang for the buck as I originally thought. But if you're like me and you like tinkering with this kind of stuff, changing the fan geometry is relatively easy to do. Again, it's thin aluminum part, bend it, twist it, do whatever you think might help make it quieter. Or louder, I guess, if you want more cooling. But instead, what I'm going to do, or what I'm going to try to do rather, I hope you're sitting down, fan on demand. Technically, I suppose it would be fans on demand. I hope these things fit. Now, the 221, the actual welder that this cooler was attached to, already does this, kind of where I got the idea. What the welder does, and you may have heard it, the cooling only comes on while you're welding, or when it needs it. And it makes for a rather pleasant experience. Maybe I can do the same thing with the water cooler. The next mod is going to be an easy-off case. I wanted to use the same fan, but as we saw, the fan and the pump are attached to the same shaft. They're mechanically coupled, so it's a little trickier to do it with the existing system. Though, if you go back to where I was placing the order for the parts, watch it really slow, you might notice that for a split second, I considered something like an electromechanical clutch, and even like a viscous connector, like a viscous fan in a car. But they were too expensive. And who knows what temperatures like a viscous clutch is designed to open and close at. Probably engine temperatures and much higher than what I need here. So the easier and cheaper option was to go to an electric fan. These are 120 millimeter fans. I should have gotten the 100 millimeter ones, though it looks like I can just squeeze them in there. If not, I might just use 2 instead of 4. So here's what I got. 4 Arctic F12s, computer case fans. I bought those, of course, because they're called Arctic, and I'm going to be putting them in an Arctic chill water cooler. They're about $6 or $7 a piece, call it $7. It's $28 just for the fans. I bought them for no other reason than the fact that they have a lot of good reviews and they're supposed to be low noise. In the middle, that's a temperature controller. It's an STC 1000. I don't even remember what brand that is, but I think all STC 1000s are the same. That's a switched temperature controller. Don't quote me on that, but I think that's what STC stands for. The 1000 is just to make it sound cool. You try it. Just pick any word and put a -1000 after it and tell me if that's not cooler. That thing costs, I think, $14 or $15. It comes with a thermocouple. We'll look at that more closely in a minute. And on the right is just a 12-volt power supply. This happens to be 220 to 12 volt because the power inside the water cooler is 220. So more or less what you're looking at is a $50 modification to the water cooler, if it works. Now this could be done for even cheaper. Like had I not gone on a fan buying bonanza and bought maybe just one larger diameter case fan, that could have knocked $20 off it right there. Second, the temperature control could have been done with just a thermostat, like a $5 microchip. And if you sized everything for the line voltage in the cooler, you wouldn't even need the power supply. You could have a line voltage case fan and a thermostat for probably under $12-15. That would do the same exact thing as this setup here. The only problem is I couldn't find any temperature information on water-cooled torches. Like there's current ratings and there's duty cycles, but nothing specifically seemed to say that the coolant inside or the water needed to be X degrees to keep the torch safe. So I wouldn't know what rating to buy the thermostat for. This is fully programmable, does heating and cooling, meaning it has, I guess, 2 thresholds you can set, cool and heat. It monitors the temperature with this built-in thermocouple, or temperature probe, and it has 2 10-amp relays, 2 outputs, one for heating and one for cooling, depending what you need this for. Basically, what this will do is monitor the temperature at some point inside the cooler and not turn the fans on until it exceeds some pre-programmed value, some pre-programmed temperature. Now, the fans, on the other hand, I'm not sure how well they'll do. These won't generate the same flow and pressure that the aluminum fan that was attached to the AC motor would. But I'm hoping to be able to get away with these, and I'll tell you why. This water cooler, I assume, is designed for professional welders, or people that do a lot more welding than I do at any rate. If you do this for a living, welding I mean, you probably have neither the time nor the inclination to screw around with the water cooler the way I am. This is just me having some fun. Not to mention the fact that you're probably in an environment where the sound of your welder and your water cooler are the least of your concerns. I mean, just look at those numbers. I'm not sure what the difference technically is between maximum cooling capacity and rated cooling capacity. I mean, I know there must be a lot of caveats to how these things are rated. Like if you're welding in the desert, this thing isn't going to have the same capacity as it's going to have if you're welding in the Arctic Circle. Coolant temperature and ambient air temperature are both going to affect how well this thing pulls heat out of your system. But again, assuming these numbers are based on some kind of industry standard, 12,800 BTUs per hour, I mean, that's a ton of cooling. Like literally, I'm not trying to be clever there. 12,000 BTUs per hour is a ton of cooling. Heck, I mean, that's the capacity of a small window mount air conditioner you might have in your house. But even the rated cooling, and even if that's over-advertised, let's say that's really, I don't know, in my conditions, in my garage, even though it's usually quite chilly down here, say that's 4,000 BTUs per hour. That's potentially a lot of heat this thing can pull out of a TIG torch for me as a hobbyist. In my haste, I neglected to open up the pump. I did want to do that. I did want to have a look at the impeller. I mean, maybe there's some opportunities there to knock a few more decibels out of the pump noise. I could still technically take it apart, but it's now full of coolant. It would make a mess, and personally, I don't trust that stuff. I don't know if I want that on my hands or in my eyes. This is just a hobby, and the last thing I want is to end up with the music in me. All right, I think all I have to do now is find some space and make some mounting hardware for these fans. Splice into some of the wiring and we can start trying this thing out. Okay, I think I'm all set up and ready to go. You saw me install the fans and the temperature controller up at the front. Now, unfortunately, there isn't a lot of space up there on the front panel, so I had to install it sort of vertically. And last, I put in the power supply and ran all of the wiring. The only thing I haven't installed is the thermocouple, or the temperature sensor. That's because I'd like to do some playing around and demonstrate how the system works. Again, it's very basic. This and the temperature controller are keeping an eye on the temperature. When it gets above a pre-programmed value, which I don't know yet, it switches an internal relay and turns the fans on. That hopefully knocks the temperature down of the coolant running through the torch, at which point the fans should go back off. Let me switch it on. And what you're seeing on the display there is the current temperature reading from the probe. If I touch that, the temperature starts to climb. I have the threshold set to 20 degrees. It only shows it there for a second. And you'll notice, hopefully, the fans at the back aren't running. So now if I hold on to this thermocouple to drive that temperature past its threshold, the temperature controller should switch the fans on. As soon as that breaks past 20, it should click over. And just one note, this thing has a 1 minute minimum delay time before it measures the temperature and turns on the load. It switches the relay. So any second now, hopefully those fans go on. They'll, of course, keep running as long as that temperature is above the programmed threshold. If I drive this down to below 20 in this case, it should switch them back off. As you may know, my right hand is cybernetic and has liquid nitrogen coursing through its veins. And there it goes. Fans are off. Let's heat it back up above 20. 1 minute delay. And the fans are back on. You switch up to the robotic hand, and the fans go off. And then all that was left to do was install the temperature sensor on the hot water side of the radiator. That's thermal paste you're looking at, just sort of slathered around there a bit, and it's tied down with some thin stainless wire. It's on there pretty good. Don't think it's going anywhere. All right, well, I think that's it. I just need to button it up and stick it in the bottom of the welding cart. Now, just a couple of thoughts. I don't know if anybody else is actually really going to try this. If you prefer to leave well enough alone, the cooler right out of the box isn't as bad as I was expecting it to be. Second, and I knew this was a risk I was taking doing the mod, the motor itself, like the main motor in the cooler, is now running in an enclosure with no continuous cooling. Like I think the cooling that the fan was doing for the TIG coolant, it was obviously also cooling down the main motor that's driving the pump and that same fan. Now it's only going to be doing that when the coolant is hot. Don't know if that's detrimental, but I guess I'll find out. And third, something I didn't see coming, just those case fans, even if they ran 100% of the time, are nearly silent. So if you could find like line voltage fans, line voltage case fans, the whole power supply and temperature sensing thing isn't really that big of a deal. Like if they were running all the time, they don't make that much noise. All that aside, I think it was a fun mod, even if it maybe wasn't the most useful. I'm really excited about having a TIG water cooler. I want to thank Jeff again for sending it, and I'll be sure to keep everybody posted on how it works out, like what temperature I end up finding to be a good threshold for the torch. That's it. Thanks for watching.